Imaginative impresarios of the image view. I'm Professor John Gallagher, and we are going to continue to work with images in SwiftUI. This time we'll write code to flip through all of the images in your app so your users flip out. But even more importantly, this lesson is about types in Swift. We'll learn about Swift's strict typing, declaring types, type conversion, and how to overcome basic type errors. And we'll run our code in the simulator so we can take advantage of the print function, which is really useful for debugging. We've got a lot on deck, so let's learn big. Now at the end of our last lesson, we added images named image 0 through image 9, but we only took advantage of image 0 and image 1 in our last app. When we click on the show message button, we flip between image 0 and image 1. But this is where we'll be at the end of this lesson. We'll be able to flip through all of our images 0 through 9, and when we get to that 9th image, we'll reset and begin showing the images starting at image 0. And before we start writing code, since we want to cycle through all of our images, I no longer need this line that sets the image name using the ternary operator, so I'm going to comment that out. And I'm also going to delete the if statement that I've commented out up here too. It just takes up space in my button action, and it makes it difficult to see all of my button code. Then I'll press return a couple times just to give myself some space to work before the closing curly in the button action. So let's think about the logic to accomplish this. And when you're learning to code, it's useful to think about the steps you perform in English and then translate them to code. Well, what we want to do is first start out with a blank image, which is what we've got, but then we want to make sure that the first image displayed is image 0. Then when the button is clicked, we should display the correct image, then increase the image number by 1. And if the image number is greater than 9, we should restart from image 0. And as we think about translating this into Swift, we realize, hey, we've got to keep track of our image number, 0 through 9. So let's do this in a state variable that we'll call image number. And it's got to be a state variable because we want to keep that value aside and we don't want to throw it out even as we update the screen and reset all of our views. So let's head to the top of our code, and we're going to create a new state variable, but we'll work with numbers instead of strings here. So let's call this image number. So we'll write @state private var image number, lower camel case, and at the end of this, instead of it making equal to a string in double quotes, when we're making something equal to a number, we just write the number after the equal sign like this, equals 0. Now here's something important to know about Swift. Variables are created to hold only a given type of data, and in our declaration and initialization statements up top, the type of variable is determined by the data we use to initialize the variable. Message string and image name are both initialized with strings. See the double quote values? So these variables are said to be of data type string, and they can only hold strings. You can never put a non-string value like a number inside of them. And if you ever wonder, hey, what type of value is this? You can always option click on the value's name, and Xcode will show you the type. So here we see after option clicking on message string that it's a variable that's of type string, image name is a string too. So what about image number? Ooh, it says it's an int. Int is an integer data type, and that can only hold numbers, and specifically numbers without decimal points. And in your code, if you even try to replace this number with a number with decimal points, Swift will complain and give you an error. And we'll look at that more in just a bit. But since image number is a number, we can perform math on it. The math we want to perform is add 1 to image number each time we click the button and display the image. So let's head down into our button action again. So to add 1 to the image number, all we need to do is write image number. And check this out, code completion knows about image number, and if we arrow down to select it, it knows image number is of data type int. So let's select that, and we'll set image number equal to image number plus 1. And by the way, you should also know there's another way to write this, image number plus equals 1. So the plus equal adds whatever on the right side of the plus equal to whatever's on the left side. And also, there's a minus equal, a star equal for multiply, and a slash equal for division. You'll see plus equal a lot in code examples, so definitely know this. Now, oftentimes when I'm writing code, I like to check the behavior each time I make a change, just to make sure everything's working like I expect it to before I write my next bit of code. So let's first make sure that 1 is being added to image number every time we click the button. And if we want to see the image number, we can use the print statement. Remember we use the print statement in Playgrounds? We can also use the print statement in our project, but 2 things to remember. First, remember print doesn't show in our final app. It'll only show in a console area. And even though we haven't seen it yet, Xcode Projects actually has a console area too. Now second, in the current version of Xcode, print doesn't work with the preview at the right. Instead, we're going to execute our code in a separate program called the simulator, and it should execute exactly as if it were running on an iOS device. Now the simulator is linked back to our Xcode project too, so if the code in the simulator has a print command, then it'll show the results printed in the console. Here's how we do that. First, to add the print command, we just enter print, and in parentheses, image number. And notice if I run in preview, I'm not seeing anything when I click on the button. By the way, the console is down here in an area known as the debug area, and you can access this by clicking on this button in the lower right-hand corner. I'll hide this now. We'll see it pops up automatically when the simulator runs. So in preview, the console shows us nothing, but we will see stuff in the console when we run using the simulator, and here's how you run it. First, you want to select the scheme or the type of iOS device that you want to simulate. Now you use the center pull-down menu here where the names of the devices are. I'm going to continue to use iPhone 13 Pro, so I'm not going to change anything here, but you could if you wanted to. Then click the play button to the left of the toolbar, and Xcode goes through a few steps, and you can see an update in the upper right-hand corner. And if your code has no errors, the Xcode hammer will indicate that your code has built successfully. When I see that, I like to yell, hammer time! Now the preview is also going to pause when the simulator starts running. The first time you run the simulator, it'll take a while. Your Mac is actually performing actions that are sort of like initializing an iPhone with a new version of iOS, and it'll do this each time you run with a different device selected in the simulator. So it'll be faster the second time I try to run on an iPhone 13 Pro, but it'll be slow again if I simulate on a different device, since Xcode tries to set that device up for the run. Also know that the larger the device that you try to simulate, potentially the slower your Mac will run, because there's a lot more to simulate with an iPad 12.9 than there is on a smaller iPhone. But eventually your simulator should pop up, and look at what you get when you run. You get this floating iPhone, you can drag it around the screen, you can click in the corners and resize it, and if we take a look back in Xcode, there's a console area that shows up down below. Now this whole area is called the Debug Pane. First, make sure that you can see the console in the Debug Pane. So there are two areas in the Debug Pane, left and right, and you can show or hide either of these using these two toggle buttons in the lower right. Now the one on the left is going to show us variables and other data structures, and it'll let us find out what's inside different variables and other values when the app is running. This is super useful when debugging, but we're going to ignore it for now. We'll cover it in a future lesson. Also know there's a dividing line between these two panes, and if you click and drag, you can change the width of each pane. And since we don't need this area right now, we can click on this icon that has a line on the left side. Tooltip says Hide Variables View, and we'll see the icon turns from blue to gray, and that pane goes away. But make sure that the second icon, the one to the right of that, with the line on the right side, is clicked and it's blue. That's going to make sure that the console shows up. And you can also click on the toolbar in the debug area and drag that up so that you've got more space to read the debug area. Now the output to the console is sometimes verbose and it contains a lot of stuff that we don't need to pay attention to. So we take a look at this first message and it's about caching for linear focus movement is limited as long as this view is on the screen. I'm not sure what that means and it's actually okay to ignore it. But the second one, it's kind of interesting. We see a message in here that says invalid asset name supplied, and then an empty string. And this actually shows up because when our app first runs, remember we set image name equal to empty string, and since our app can't find an image named empty string in our assets catalog, we generate this error. Now this is the kind of error that doesn't crash our code. iOS just shows nothing in the image view, and I knew this would happen, so that's fine. And for some reason, we see this error shows up a few times. This has to do with the fact that iOS is actually refreshing our screen multiple times when the app first runs. Each time it does this, it generates this error, but at this stage in our app development career, it doesn't concern us that SwiftUI is updating that image multiple times when it first runs the app. You can just consider it to be one of the mysteries of iOS. But do know that even though we're getting this error, it's not the kind of error that crashes our code. Our app is working fine. But let's see what happens when we click our button once. And hey, we see 1 is printed out. This came from our print statement right here. And remember, this shows up because we first initialize image number to 0, then we add 1 to it, then we print it out, so we get the 1. Cool. Let's keep clicking, and all right, we see 2, 3, 4, 5, 6, 7, 8, 9, and we go to 10, 11, 12, 13. We don't want that. When we hit 9, we want to go back to 1. How can we fix it? Let's call on our friend the if statement. But before we add the if statement to our code, I want to show you a few more things. Now I want to return to Xcode, and you could quit the simulator. It's connected to Xcode, but it's actually considered a separate application that's running. But pro tip, if you keep the simulator running, the next time you run code using the play button, the new code will run in the simulator and it should start faster since the app doesn't need to launch and set up. But I also want to show you what happens if you do quit the simulator while code is running. So I'm going to do that now, and what you see is the Navigator pane changes from Project Navigator to the Debug Navigator. And it shows you some cryptic content, and it might even change the code editor to a completely different file. This just happens because when we quit our simulator, Xcode was following what was happening in the simulator, and it looks like our code was crashed. Now you might also see something like this if your code really does crash because there's an error in your code, but this happened because we quit the simulator, so no worries. You can get back to the Project Navigator by clicking on the folder icon in the far left of the Navigator pane, then click on the file of the code that we were working on. For us, that's the content view. And I'll hide the Navigator pane and click to the right on this icon that hides the Debug Pane. Now we also see that our preview paused. You can restart it by clicking on the resume button, the circular arrow, or you can type Option-Command-P. Now, before we enter an if statement, we're also going to want to update the image name, and we do that just before we increment the image number by 1. Now, I don't want to do that now, so I'm going to enter a comment. When I do this, I want to introduce you to annotated comments in the Xcode jump bar. So I'm going to enter a comment this way with 2 slashes and then the keyword to do, one word, all uppercase, followed by a colon. Now, notice as soon as I do that, the comment gets bold, and I can write my comment after the colon. In this case, I'll say update the image name variable. Now, to do is actually a special comment annotation in Xcode, and there are other annotations too. The all caps word fix me and the all caps word mark will also show up prominently, and these are useful because they can help you quickly spot things that are important and might need updating. Now, if you consistently use the word to do in your Xcode projects, then you can use Xcode's find feature. Like most apps, you can bring up the find command with Command F, and you can search for a phrase like to do and find it. But there's also a jump bar in Xcode, which we haven't used yet, but it's pretty useful. And it's at the end of what's sometimes referred to as the breadcrumb trail, just under the toolbar. See how this shows where we are in our project icon, you are awesome, then folder, you are awesome, then the little Swift shows the file that we're in, which is content view, and the last item in the breadcrumb trail will be different depending on where we've clicked in our code. So currently it shows my comment, but if I click above this, it shows body. That indicates that the cursor is currently in the body portion of my code. But we can click and pull down the last item in the breadcrumb trail, and we see a list of parts in our code. Now, the P next to some of these items stands for property, which could be variables or constants. And if you want to jump to one of these areas in your code quickly, say you want to go where the image number was defined, you could select this and your code will automatically scroll to that part. Now, I mention this not only because the jump bar can be useful as you write more code, but also notice the icon in my pull-down menu that looks like a little indented clipboard. That's my to-do comment. So the to-do and other annotations get a call out like this in the jump bar. So the jump bar provides another easy way to look at a file and easily see if there are any lingering to-do comments that you need to pay attention to. So again, common annotations in Xcode are /to-do, fix me, and mark. And in fact, you can make them stand out even more prominently by surrounding the comment with dashes like this. See how when I pull down the jump bar, the to-do comment now has lines around it? Handy. So now let's add that if statement, and we want to put it just below where we add one number to our image number. And we'll see if image number greater than 9, open and close curlies, image number equals 0. And now let's click the play button to run the simulator and try this out again. If you get a message asking if you should replace the existing code in the simulator, yes, that's okay, replace it. No errors, hammer time. Let's click our button. 1, 2, 3, 4, 5, 6, 7, 8, 9. Moment of truth. Click again, and we're back to 0. Nice! Now I won't quit Xcode this time. I'm just going to Command Tab to switch back to the Xcode program. Command Tab in Mac OS will switch between open programs. Notice there's a little square button which is now active next to the play button. That's the stop button, and if you click that, it stops the link between Xcode and any code that's running in the simulator. I'm also going to hide the debug pane since I don't need that anymore, and I'll click to resume the preview, and let's update this to-do item. Now you might be tempted to just write something like this. So before we add a number, since we start with image number 0, and we want to display that, you might want to enter image name equals, and then the string literal image plus image number, right? Looks good, but Xcode gives us an error. And if you click on the little red error circle, it says cannot convert value of type int to expected argument type string. Oh yeah, image name is a string, but image number is an int, and we learned that in Swift we can't combine values that are of different types. And so to explore this concept a little bit more, it's going to be useful to jump into a playground. So let's do that now with File menu, New, Playground. Select blank. I'm going to name this Types Playground. I'll resize the playground window and hide the left pane. And we'll return to the playground in a bit, but as I show you some concepts on the slides, you're welcome to type some of those things into the playground to try them out. Now let's take a look at the most common Swift data types. Now we've already been working with strings, and just about anything you can put between double quotes will be considered a string, including emojis. We've seen double quotes with nothing in the middle is also a string. That's called the empty string. That's a string with length 0. And a number between double quotes is also a string. But try to assign a number directly to a string without double quotes, and that's not allowed. You'll get an error. Now we've also talked about the Boolean data type. That type is the Bool type in Swift. And those values can be either true or false, nothing else. And true or false also has to be in lowercase. Capitalize true or false, and that'll cause an error. And try to assign the word true or false in between quotes to a value that's already been declared as a bool, and that'll give an error too, because false with quotes is a string, not a bool. Now in this lesson, we've introduced the integer data type, or int. And ints are whole numbers. They can be negative values or 0, but they can't have decimal points. Now there's some other rules for ints too. They can't have commas in them, no currency symbols, and no percent characters. So the number 5, that's an int. 0, that's an int. The larger number 1, 2, 3, 4, 5, 6, 7, 8, all ints. But a 5 in quotes, that's a string, not an int. Any number with commas is going to generate an error. You can't have commas in numbers in Swift, and that's because commas have a special role in the programming language. And we've already seen that. Commas are used to separate different values in a function call. So if you had commas in an integer, that would be considered 2 different values. Also, percentage signs at the end, no good. That'll get an error. Again, no $sign or other currency symbols. And once a value has been defined as an int, you'll get an error if you try to set it equal to a value with a decimal. And there are a lot more data types, but the last major data type we'll introduce is the double. Now, doubles have decimal values. They can be positive or negative, and also like ints, no commas, currency symbols, or percentage signs. Now, 1.6, that's a double. And here's an important point. If you've already defined a value as a double, like I've done with var myDouble, then I can assign a literal value without decimals to that value, and Swift will automatically consider it to be a double. But be careful, because if I declare a value and initialize it with a 0 and no decimals, then Swift is going to assign the value type as an int. Need to declare a value as a double and initialize it to 0? Just set it equal to 0.0. Same thing with the literal value 4. Since myDouble was already initialized as a double, then if I replace it with the value 4, Swift is going to consider that 4.0. It's still a double, you won't get an error. Really long decimal values, those are okay. Now, if you're working with extremely large or extremely small numbers, you can search online for tutorials on how to deal with large numbers, but doubles will be fine for the vast majority of app ideas. Now, 1.6 in quotes, that's a string. Assign that to a variable that's already been declared as a double, and you'll get an error. No currency symbols allowed, and if you have a variable that's been defined as an int like myValue and you try to assign that value to a double, that'll generate an error. So this is important to know. Swift will convert literal values to doubles if you try to assign them to a value that is already a double. So the 0 will be considered 00, 4 will be considered 4.0, but it won't do this for constants or variables that have already been defined as integers. This would generate an error. Now, because Swift has such strict data types, it's often called a type-safe language. It's kind of like the classic children's toy that has blocks of different shapes and holes of different sizes that the shapes fit into. Well, if you think of a string as being, say, a square block, and an int as being, say, an oval block, you can't put a string in an int hole or an int in a string hole. Now in Swift, if you want to combine data or perform calculations, those values need to be of the same data type. You can concatenate a string with a string or perform math on an integer and an integer or a double and a double, but the reason why our code generated the error is because we tried to combine a string with an integer. And in Swift, combining values of different types is not allowed. In fact, you can't even combine numbers of different types. So it's not okay, for example, to multiply an int by a double, which to a non-Swift programmer seems really weird. Now, as a programmer, this requires a little bit of work up front. You've got to think about what type of data you're going to be storing in a value, but in the long run, this is going to make your code far more reliable. The reason why Apple chose to make Swift a type-safe language is because there are a huge portion of errors in other programming languages that are the result of using the wrong value in a type that was expecting something different. So with a type-safe value, you'll have fewer errors in executing code, and if Swift is your first programming language, you'll learn better practices right out of the gate. So now let's head back to the playground and try out some of these techniques, and feel free to try out some of the examples from the earlier slides in your playground. Entering correct and incorrect values for data types can really cement your understanding. For example, we know that numbers can't have currency values or commas, so if we enter a value like developer salary equals $175,000 a year with a $sign and a comma, we see Xcode underlines both the $sign and the comma as problematic, but if we remove those values, everything works fine, and you can even include the underscore as a placeholder too. Cool. Now to replicate what we had in our project, it's something like this. var image number equals 0, var image name equals empty string, and what we tried to do was image name equals, and then the string literal image plus image number. If we try to print that out, shift return, same error. Cannot convert value of type int to expected argument type string. If we option click on image number, we see, yep, that's an int. Option click on image name, we see, yep, that's a string. Try to combine different types? Swift says no can do. But one way we can fix this is by wrapping the integer in the keyword string and parentheses. So preface integer with type name string, capital S, types are always upper camel case, then follow this with the parentheses surrounding the value that we want to convert to a string. Now that doesn't convert image number to a string. Image number is still an int, so if you access it after this, you'll still get an int. But what it does do is it extracts the value inside of image number and converts that to a string for use in this equation. So here we're able to concatenate a string with a 0 in it, to the literal string image. And we see if we shift enter, the error goes away and our code works. And you can see over here in the results pane that image 0 is written as a string between double quotes. So using the type name and parentheses for string conversion is a new method for us. I'm going to comment this out with a command /, but you might already have had an answer for this because we learned another technique that we could use in an earlier lesson. Remember string interpolation? We can write this too. Image name equals the string image, then inside the double quotes, I write the string interp / open and close parenthesis, then in between the parenthesis, I can use code completion, bring in image number, Shift Command Enter, the console flashes, and once again we get image 0. Nice! And while we have our playground open, let's work through one more example involving numbers. This shows a common error for new Swift programmers. Say you've got a fitness app and you're trying to convert the miles that you've run to kilometers. And you define miles like this. Let miles run equal 3, and kilometers per mile like this. Let km per mile equal 1.609. Well, if you try to calculate kilometers run, with let km run equals miles run times kilometers per mile, you get an error. Try to print out km run, but the error is binary operator star, meaning the multiplication, can't be applied to operands of type int and double. Option click on miles run, that's an int. Option click on km per mile, that's a double. But the same technique we learned with strings also works with double. So if I preface miles run with double, then surround it with parentheses, shift enter, and look at that. We recalculate properly. The miles run, which is 3, is extracted, turn it into a double, 3.0, and the multiplication works. Cool. And you just ran 4.827 kilometers. Now I'll show you a couple more techniques that could have prevented this error. We could have forced the value miles run to be a double. Let me comment out our old let km run line first. We could have simply declared 3 as 3.0 instead. The 0.0 is a decimal, so Swift implicitly defines this value as a double. And then if we write this line, km run equals miles run times kilometers per run, we get no errors because if we option click on miles run is now a double. And there's also a method to explicitly declare a value as a type. So if I go back to setting miles run to 3 without the decimal, I could add a colon after the value name, then type, in this case, double. This tells Swift to explicitly declare the value miles run as a double. Regardless of whether it has a decimal or not, Swift will treat this as 3.0, not 3, shift enter, and explicitly declaring the value type works too. Nice! So now let's command accent back over to our project, apply one of the techniques we just learned, and fix that error in our app. So now we know inside of this image string literal, we can just add the string interp, / open and close parens, cut out the image number, delete the plus, paste image number in between the parens. I'll click the resume button. I can also delete the print. I don't need that anymore. Moment of truth. Let's click show message. No errors in our code. Preview's running. 1, 2, 3, 4, 5, 6, 7, 8, 9. What happens when we click again? And we're back to image 0. Nice! Click away, you're flipping through images. Outstanding work, Swifter! I'll just clean up my code because I no longer need this line with the image name and ternary operator, and I can get rid of the to-do comment as well. Once again, big learning in this lesson. We learned about major data types in Swift, strings, bools, ints, and doubles. We covered Swift's strict type declaration and learned how to implicitly and explicitly declare a type. We learned the ultra-handy option click to show a type's value. We encountered several common errors using Swift types and learned how to prevent them. We covered type conversion, using the type name in parentheses, and using string interpolation. We learned the numeric placeholder, underscore, to make it easier to read large numbers, given that you can't use commas in Swift numbers. We worked with the simulator and learned a few simulator use tips, and used print for debugging and showing the status of a running program. We saw the debug area and the Xcode project console for the first time. We learned the operator shortcuts plus equal, minus equal, star equal, and slash equal. We work with annotated comments to do, fix me, mark, and we learned how to add divider lines to those comments. We used the Xcode jump bar, and we saw we can use Command F to find. Good gravy, Swifter! You are not only learning Swift and SwiftUI, you are getting lots of useful tips and tricks along the way. Feel good about those skills and buckle up because there's more big learning coming at you. Keep at it!